Okay, hi everybody. I'm so sorry that I'm not there in class with you today, but I wanted to make this video lesson to walk you through the lesson that we're going to be doing and hopefully give you enough information that you can start your homework successfully. So today's lesson is called Sequences and Series, and we are going to start by talking about sequences. So a sequence is a pattern in which a relationship exists between the terms. And we're going to be talking about two types of sequences today. But first of all, we're also going to define some vocabulary. So we're going to use n to define the number of terms in the sequence. So the 10th term would be n equals 10. And then we're going to use tn, it's a little subscript n, to refer to the term itself. So the 10th term would be t10. If we don't know how many terms there are, we just use n. If we don't know which term in the sequence it is, we call it tn. And this will make more sense when we start getting into some examples. So the first thing we're going to do is we're going to learn to develop an explicit formula. And what this does is it relates tn to n. So let's try an example. We're going to consider the following sequence: 5, 7, 9, 11. And we can probably see right away that the pattern here is just that we're adding 2 every time. But the question is, so if I wanted to find the 5th term in this, I just add 2, it's 13. If I want to find the 6th term, I add 2. But if I wanted to find the 50th term, or one that's further along, this is why we would use an explicit formula, because it's going to allow us to actually get further along in the sequence. And we're going to essentially find this by creating a pattern. So t1 is equal to 5, t2 is equal to 7, but I'm going to write this as t2 is equal to 5 plus 2. t3 is equal to 5 plus 2 plus 2. t4 is equal to 5 plus 2 plus 2 plus 2. And what you might notice is that the number of 2's here is actually 1 less than the number of the term. So t4 is equal to 5 plus 2 times 3. t3 is equal to 5 plus 2 times 2. So 1 less the number of terms. So we can extrapolate from here that t50 is going to be equal to 5 plus 2 times 49, which is 103. Okay, now this example is something called an arithmetic sequence. There's a weird pronunciation. It's not arithmetic, it's arithmetic in this particular case. And an arithmetic sequence is one that is formed through addition or subtraction. So now we're going to generalize this and find a formula that's going to be helpful to us in all cases. So we're going to use the letter A to represent the first term, and we're going to use the letter D to represent the common difference, which is the amount that's being added every time. So if T1 is A, T2 is A plus D, T3 is A plus D plus D, and so on, T50 is going to be A plus 49D. And Tn is going to be A plus n minus 1 times D. And this is one of the 4 formulas that we're going to be learning today that you are going to be using in order to very quickly and easily get your answers. So let's apply this now. We're going to write an explicit formula, meaning we're going to use the formula we just made to represent the sequence 19, 15, 11, 7. If you want to pause the video here and try it yourself, please go for it. And I will walk you through it now. So Tn is equal to A plus n minus 1 times D. And we know A is our first term, so that's 19. N minus 1 is going to stay as n minus 1, and then D is the common difference. This is the amount that's being added every time. You'll notice in this case the amount that's being added is actually negative. I'm adding negative 4 every time. And so this is the most consistent way of doing it. If you would like to simplify this, you absolutely can. You can simplify this by distributing in the negative 4 and simplifying like so. But you don't have to.